All right, our last video for Chapter 5. Chapter 5, application problems. So, our objective for this video will be able to apply quadratics to real-life situations. All right, so the first example we have here, the profit from selling local ballet tickets depends on the ticket price. Using past receipts, we find that the profit can be modeled by the function p is equal to negative 15x squared plus 600x plus 60, where x is representing the price of each ticket. Now, with this, we want to find A, the ticket price that gives the maximum profit, and B, what is that maximum profit. So if you think about this situation, you're running a ballet, okay? You sell your tickets for a low price, you're not going to make much profit. Okay, if you sell them for too much, you're going to get less people at the ballet. So again, your profit dwindles there. Okay, there's that happy medium where you're going to maximize your profit. Okay, so we want to find that happy medium where we get the maximum profit. So if you think about it, here's our equation, and it's a quadratic. So it's going to look something like that. It's going to be a parabola that opens down. Now, if we want to find the maximum profit, okay, the maximum point on a parabola is the vertex. Okay, so we want to find the vertex for x and y. And if you, again, x is representing the ticket price, and then y will be representing the profit. Okay, so our goal here is to find that vertex. X is that ticket price that we need to sell it at, and then y will be that profit that we make. Okay, so let's go ahead, let's find the vertex in this case. And again, to find the x coordinate of a parabola for the vertex, negative b over 2a, which will be negative 600 over 2 times negative 15, which will give us negative 600 over negative 30 to give us 20. Okay, so that's our x coordinate of the vertex. Let's go ahead, let's find that y coordinate by taking that x coordinate, plugging it in. So we got negative 15 times that 20 squared plus the 600 times 20 plus the 60, which will give us negative 15 times 400 plus 600 times 20 plus 60. Go ahead, plug that into your calculator, and you will get 6,060. So there is our vertex. Now to actually answer those questions, so A, okay, it's asking for the ticket price that gives the maximum profit. And again, the x coordinate is representing the price for each ticket. So we want the ticket price to maximize the profit. Will be $20. Okay, now part B, it's asking for that max profit. So the maximum profit will be $6,060. So the big thing with these problems is understanding what each coordinate actually represents. Okay, so anytime you find the maximum, finding that vertex. In this case, the x coordinate represented that ticket price, where the y coordinate represented the actual profit you make. All right, so that's the first example. Second example 2. Okay, we're talking about dropped objects or launched or thrown objects. So what we need to know are these models. So as of right now, let's go ahead, let's ignore that top one. Let's just walk through what each part of these models represent. Okay, h is representing the height, okay, and I like to think of it as the final height. Okay, t is representing that time. H sub o, that's representing the initial height. Where does that object start? And then finally, v sub o is the initial vertical velocity. So when it comes down to these problems, it's being able to break down what you know. Okay, are we given the initial height? Are we given the initial vertical velocity? And then plugging that into that model. Now, if we think about it, okay, the reason I just crossed out the object that is dropped that's where the v sub 0 is just 0. Okay, you're dropping an object, it does not have an initial velocity, so these two are technically the same, it's just that v sub o is 0. All right, so let's look at the example. A ball is shot from a cannon into the air with an upward velocity of 40 feet per second. Okay, right there, that is our initial vertical velocity. It's shot upwards. Okay, write an equation that gives the height h of the ball at any time t. So when we write this, we have v sub o, which is 40. Okay, it is positive 40 due to the fact that it is being shot upwards. If it was a case where it was shot downwards, that is where the initial velocity will be negative. Okay, so that's the only thing we're given. So we're going to take what we know and plug it into the model. H, okay, we don't know the h, is equal to negative 16 t squared. I forgot to mention this, that negative 16 t squared will never change. That is the part that is taking gravity into effect. Okay, so negative 16 t squared will never change, that's gravity. Okay, plus v sub o t, so 40t, and we had an initial height of 0. Okay, we're starting on the ground if we're shooting from the ground. So there's our model for the situation. H is equal to that negative 16t squared plus 40t. Now it says find the maximum height attained by the ball. So this is, again, just like a situation like this. We're trying to find the maximum height. Okay, so when we're doing this, we need to find the vertex. So let's go ahead. X is equal to negative b over 2a, negative 40 over 2 times negative 16. So negative 40 over negative 32, which ends up simplifying to 5/4. Now, since we're talking about a real life situation, let's think of that as time, which is also 1.25. Okay. Now, the x coordinate in this case is the same as t. Okay, that's our time. So that's how long it takes to get to that maximum height. The y coordinate of that vertex is what's going to actually represent the maximum height. So we got to plug that back into, and let's go ahead, let's actually use that h. Okay, the height is equal to that negative 16 t squared, which we said was 1.25 squared, plus 40 times that 1.25. Okay, go ahead and plug that into your calculator. You're going to end up getting 25, which is representing that maximum height. Okay, so the max height is 25 feet. Now, the next part, how long did it take for the ball to reach the ground? Okay, so that's when we're looking at that final height. Okay, if it hits the ground, that means we're at a height of 0. So we're plugging h, or 0, in for that h. Okay, let's go ahead, let's do that in blue here. So we're going to get 0 is equal to that negative 16t squared plus the 40t. Okay, and it's asking for how long did it take, so that's asking for time. So in this case, we need to solve for t. So what I'm going to do is I'm going to try to factor. Okay, greatest common factor, both terms have a t, so I'm going to take out a t. T is equal to negative 16t plus 40. Okay, from there, again, solving by factoring, we set each of these factors equal to 0. So we're going to get t is equal to 0, and then that negative 16t plus 40 equals 0. Okay, now I would bring that 16t over, so we're going to get 40 is equal to 16t. Divide by that 16, and we get t is equal to 2.5. Now, if you think about this situation where we launch the ball, so here's the cannon. It starts on the ground at 0, and then it's going to go follow this path, and then hit the ground here. Okay, this is 0 seconds. This would be that 2.5 seconds. Okay, and again, this was that maximum height, which took 1.25 seconds to get to, and it was at a maximum height of that 25 feet. All right, so 2.5 seconds to hit the ground. Again, these are all word problems, so we are answering them with words, a sentence. All right, now the last part of this one, how long does it take the ball to reach a height of 20 feet? So this right here, that's at 25 feet. So in this question, it's asking, when will it hit that 20 feet? It will hit that 20 feet at 2 different times, and we'll be able to figure out both of those times. Now, so in this case, we're looking for that height here to be 20. So we plug in 20 for H. And then again, we're asking for time, so we're going to solve for T. So in order to do this, we're going to set it equal to 0. And bringing that 20 over, it'll change it to minus 20. Now, this is a case where I'm probably going to go with quadratic formula. So instead of x, it's t. I'm just replacing t with x, or x with t. So negative b, we get negative 40 plus or minus the square root of 40 squared minus 4ac all over 2 times a. And when you plug that in to your calculator, you're going to get 2 different times. Okay, you'll get the plus or minus, and you'll have to do negative 40 plus that square root over negative 32, and then that negative 40 minus that square root over negative 32. So the 2 times you're going to get is going to be that 0.69 seconds and then 1.81 seconds. Now, the question's asking when did it reach that height? So that's asking for that initial time it hit that, which will be that first time. Okay, so it will take 0.69 seconds to reach 20 feet. Now, if I was to ask when did it fall to 20 feet, okay, that's where we would ask for that second time that it hit that 20 feet mark. All right, so that's that example. A little long, but not too bad once you get it broken down. All right, so for the next one, you drop your cell phone while in the bathroom in front of the mirror while the water is running in the sink below. If you are 1.5 feet above the sink, how long did it take? How long do you have before the cell phone is a goner? Okay, so again, let's break down what we know. Okay, so height, we got our initial velocity, and we got the initial height. Okay, so initial height, that's going to be that 1.5 feet. That's where it started. Okay, and in this case, we're dropping the object. Okay, so that's a case where the initial velocity is 0. Okay, and then how long do you have before the cell phone is a goner? If that's the case, that means that the cell phone actually hit the bottom of the sink. So we're looking for a height of 0. So in this case, we're looking at 0 is equal to negative 16 t squared. Again, that part does not change. Plus 0t, we don't need to worry about that. Plus that 1.5. And remember, h is equal to negative 16 t squared plus v sub naught t plus h sub naught. Okay, so just plugging in those values that we had. Okay, the h for 0, the 0 for there, and then finally the 1.5 for our initial height. Okay, so solving this now, okay, again, it's asking for the time that it's going to take. That means we need to solve for t. I see a quadratic term and a constant term, so this is a case where I'm going to solve by square rooting. Again, I don't care how you solve it, but remember, this is going to be the most efficient method. Okay, so we divide by 16. We're going to get t squared is equal to 1.5 over 16. And here's the other part. At this point, we're solving for t, so this is exactly how you can solve it. You can just plug it right into the calculator. Square root of 1.5 over 16. Okay, so when you do that, you're going to get plus or minus 0.31. Now, unless any of you are time travelers, the negative does not make sense. So we're only going to use one of those answers. So it will take 0.31 seconds for the phone to hit the sink. All right, that's that problem. Now, how long would your phone be falling if you were able to snag it 0.3 feet above the sink? So in this question, we're just changing that initial height. Instead of it hitting the bottom of the sink, we're catching it 0.3 feet above the sink. So in this case, 0.3 is equal to that negative 16t squared plus the 1.5. Okay, same idea. It's asking for how long, so we're solving for t. Setting it equal to 0, subtracting that 0.3 over, we get negative 16t squared plus 1.2. I would use that same method of solving, so we're going to get negative 16t squared is equal to 1.2. Divide by that negative 16, you end up with t squared is equal to 1.2 over 16. Oh, that's a positive there, sorry. Okay, square root, t is equal to plus or minus 0.27. And again, we ignore the negative, so the phone will be falling for 0.27 seconds. Now, if we think about this, okay, it took 0.31 seconds to hit the sink, so if we were able to catch it before it hits the bottom of the sink, that answer should be less time than the one above. Okay, and if you think about it, if you drop a phone from 1.5 feet above whatever, it's not going to take very long, so that 0.31 makes good sense. Okay, same thing with the catching at 0.3 feet above. All right, we are going to ignore this problem. Okay, example 4 now. A man tosses a penny up into the air above a 100-foot deep well. So we got this 100-foot well. So from here to here, that's 100 feet. Now, he has an initial velocity of 5 feet per second, and the penny leaves the man's hand at a height of 4 feet. Okay, so that initial height is actually 4 feet above that 100 feet. Okay, so how long will it take the penny to reach the bottom of the well? So let's break it down. H is going to be the final height. So where are we looking to see where this penny ends up? We're looking to see it end up at the bottom of the well. So we're going to think of the bottom of the well as 0. Okay, so and then initial velocity. Okay, he flipped it up, so it's going upwards at 5 feet per second. And then the initial height, this is kind of the tricky one. Okay, it's 100 feet to the top of the well, plus that 4 feet to the man's hand. So our initial height is 104 feet. Okay, so let's go ahead. Again, h is equal to negative 16t squared plus v sub naught t plus h sub o. Now, I haven't mentioned, you will need to know that formula. Okay, I will not provide that, so make sure you know that. Plugging in what we know, 0 is equal to that negative 16t squared plus 5t plus 104. Okay, so again, it's asking for how long will it take for that penny to reach the bottom. So again, we're solving for t. So in this case, again, I would use quadratic formula. So taking that, t is equal to negative b, so negative 5 plus or minus square root of b squared minus 4a times c all over 2 times a. Okay, we plug that in. You're going to, well, let's walk through this a little bit. So t is equal to negative 5 plus or minus the square root of 6,681 over negative 32. So when you're figuring out those two values, you're going to go to your calculator. You're going to plug in -5 plus the square root of 6,681 divided by -32. And then again, -5 minus that. And these are the two answers that you will get. Now, one of them is negative, one of them is positive. Again, negative time does not make sense. So we're going to take the positive. It will take 2.71 seconds for the penny to reach the bottom of the well. Again, the big thing is coming up with that model for the situation. So breaking down your initial height, your initial velocity, your final height, and plugging it into the formula. All right, one more. A baton twirler tosses a baton into the air. The baton leaves the twirler's hand 6 feet above the ground and has an initial velocity of 45 feet per second. Okay, the twirler catches the baton when it falls back to a height of 5 feet. For how long is the baton in the air? Okay, so just from that second sentence, okay, we get the initial height of 6 feet, and we get the initial velocity of 45 feet per second. Now, we haven't written a model for a situation yet, so let's go ahead, let's do that. So when I say a model, that's representing the whole situation. Okay, so h is equal to, well, we should say h of t, because it's in terms of time. Okay, -16t squared plus that 45t plus the 6. Okay, so that's the equation that we would use for if I asked the 5 feet, or if they caught it at 6 feet, or any other place. Okay, now for that specific question of when it falls back to 5 feet, that's where we're plugging 5 in for h. But if I was asking for a model, that equation of -16t squared plus 45t plus 6, that would be the model for this situation. Okay, so for this specific situation then, where it's at 5 feet, we're going to plug 5 in for that final height. Okay, and then we're going to want to solve for t, because how long is it taking? So 0 is equal to that -16t squared plus 45t plus that 6. Oh, we had to subtract that 5 over, so plus 1, sorry. Okay, because we had to subtract that 5 over. All right, now again, solving for t. Let's go ahead, let's solve using the quadratic formula. -b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right. So let's break this down. -45 plus or minus the square root of, give me 1 second here, 45 squared minus 4 times -16 times 1, 2,089 over -32. Okay, so again, we're going to get two answers. So if we did -45 plus the square root of 2,089 divided by that -32, first answer we get -0.02. Again, that's a negative time, so we're not going to worry about that one. So -45 plus the square root of 2,089 divided by that -32. Oh, -45 minus that square root of 2,089 divided by -32. You get 2.83 seconds. Okay, so that answer makes sense. So the baton will be in the air for 2.83 seconds. All right, and then just think about, like, when you do these problems, make sure that they make sense. If you're a baton twirler and you throw a baton up in the air, you know, it's not going to be up in the air for 70 seconds, 60 seconds. Okay, it's only going to be up there for, 2 to 5 seconds. So that answer makes pretty good sense. All right, that was application problems. Your homework is the application practice worksheet. Okay, so in the homework, application practice, it will look like this. Make sure you work through that, check your answers, and if you have questions, let me know. Otherwise, have a good day.